A British physicist J. Thomson measured the ratio of electrical charge to mass ratio by using cathode ray tube and applying electric and magnetic field perpendicular to each other as well as to the path of the electrons. When only electric field is applied, the electrons deviate from their path and hit the fluorescent plate towards a positively charged electrode. When only a magnetic field is applied, the cathode ray strikes the fluorescent plate in the opposite direction of the electric field. That is, in electric field, it moves in upward direction, but in magnetic field, it moves in downward direction. In the absence of electric or magnetic field, these cathode rays travel in a straight line. J. Thomson, carefully balancing the electrical and magnetic field strength, it is possible to bring back the electron to the path which is followed in the absence of electric or magnetic field, and they hit the screen in a straight line path. J. Thomson done accurate measurement on the amount of deflection observed by electrons on the electric field strength or magnetic field strength. So he was able to determine the value of E by M ratio. He found that E by M ratio value is 1.758820 into 10 to the power of 11 coulomb per kilogram. Here Me is the mass of the electron in kilogram and E is the charge on the electron in coulomb. J. Thomson said that the amount of deviation of the particles from their path in the presence of electric or magnetic field depends upon the following points. They are: when the magnitude of the negative charge on the particle increases, the deflection in the presence of electric field or magnetic field is also increases. Second point, the mass of the particle decreases, deflection will be greater. Third one, if we increase the strength of the electrical or magnetic field, the deflection also increases.